Question number 23 is asking us to describe the trend of the cooling curve. Notice that they italicized the word cooling. When we go back to table 2, we notice we have a cooling curve and a heating curve. You have to understand that the cooling curve graph is read opposite from the right to the left so that the temperatures go down as you cool it. So I see that it stays level, drops down quickly, and then levels back out. When we look at our answer choices, D matches that trend. Question 24 is asking us to predict which of the following DNA strands would most likely have the lowest melting temperature. To find this answer, we need to go back to the very beginning where they describe the experiment. They say when DNA is heated to its melting temperature, it denatures and breaks into two strands. When cooled, the strands can relink to form less stable DNA, indicated by a lower Tm. That means I'm going to want to choose the one that has been most denatured and most unlinked, the choice J. Question 25 is asking us if figure 3 supports the claim that two linked strands exposed to UV light will gradually break them more and more bonds the longer they're exposed to the UV light. So we need to go to table 3, and in table 3 we notice that the trend is as the exposure time goes up, the melting temperature goes down. Therefore, remembering from the previous question, though a lower melting point is going to indicate a less stable molecule. Therefore, we're going to say yes, as exposure time increased, Tm only decreased. Question 26 is asking us which of the following graphs best represents a solution that has a melting temperature 10 degrees lower than the Tm in figure 2. So we need to go to figure 2 and we see the Tm for the heating curve, which is what they were asking about, was 80 and the cooling curve was 70. Therefore, when we go back to this, 80 minus 10, that gives us our 70, and we're looking for a heating then of 70, choice F. Question 27 is asking us how the DNA molecules that were heated and then cooled compared to the DNA molecules prior to heating. So we go back to figure 1 and we notice that the DNA strand picture is completely linked. We heat it, they unlink, it cools, and then they rebond, and then rebond more, but each time further cooling, they become less and less linked. Therefore, we're going to say that choice A, two completely linked strands only in the beginning. After heating and cooling, each DNA molecule is composed of more than two linked strands.